Hello everyone. In this video we will see how to convert an image to its negative using MATLAB. So here image negative is turning a photo into its exact opposite, that is lights becomes darks. Now here in this particular program, first we will read an image, then we will check whether the image is a colored image. If it is a colored image, we'll convert it to grayscale. Or else if it is not a color image, then we'll use the original image and then we will create a negative image. Then we will display the original image along with the negative image. Here we are using the command size of image comma 3. First we will see what does the command size of image return. So here for a grayscale image, it returns m cross n. That is, for example, here we'll get 256 cross 256. If it is a colored image, that is RGB, then we'll get one extra term here. That is, it returns m cross n cross 3. 256 into 256 into 3. If it is a grayscale, then we'll get only 256 into 256. If it is colored image, then we'll get it as 256 into 256 into 3. Now, what does this size image comma 3 mean? Okay, as we are using this in our program, it means that this command, it will extract the third dimension of the image. If it's 3, the image is colored. That is, the image is RGB, it is not a grayscale. If it doesn't exist, suppose if we have only 256, we don't have 3, third dimension is not present, then it means that the image is a grayscale image. So now why do we use this? We are using size of image comma 3 to check whether the given image is colored image or a grayscale image, so that if the given image is colored, we can convert it to grayscale. Now we will have a look on the program. So we'll start our program with the 3 basic commands: CLC, clear and close all. Next what we'll do is we'll read the input image using the command img is equal to imread. Okay, I have copied the path. You can copy the path of the file whichever you want to use, or the image whichever you want to use. Image img, I am using this variable. You can use any variable of your choice. I am using it as img is equal to, img is my variable, img is equal to imread, then the image. Okay. Next, we will check whether the image is a colored image or a grayscale image here in this particular part of the program, from this line to this line. So here we use the function size of image comma 3. Okay, if the third dimension is equal to 3, it means the image has 3 color channels, that is the red, green, blue. So we convert it to grayscale by using RGB here, RGB to gray of IMG. IMG is our original image which we have given. Now we are checking if it is equal to 3, then it means that it is a colored image. So we need to convert it to grayscale. So I have used the variable img underscore gray for the gray image. Img underscore gray is equal to RGB to gray. We are converting RGB image to gray image. Okay. Or else img gray is equal to img. If the given image is in the grayscale, then there is no need to convert. We will directly get that image. Now next what you have to do is we have to apply the formula for the image negative. So for that we will use negative underscore image is equal to 255 minus img underscore gray. Img underscore gray is the gray level image which we have obtained, and here this is the formula. This is negative underscore image is a variable which I am using for the negative image. So here this formula or this particular line, it inverts all the pixel values. That is, it will mark the dark areas bright and the bright areas dark. Now finally we will display the images side by side using the subplot and IMShow commands. So here I am using 1 row and 3 columns to display the images, because I want to display all the 3 images. First image I have given the colored image, so that will be my original image. Then I have converted that to the grayscale image. So the second column, first row, second column. Second column image will be the grayscale image and the third column will be the negative image. So here this subplot, it will create one row. This first dimension is for the row, second dimension is for the column, and third is where we are placing our image. So here I am using one row, three columns, and I am placing the original image in the first place. That is the first quadrant, suppose. Now IM show of image, it will display the image. Okay, this figure, it will create a figure. That is, it will create a figure window. Okay, figure window where you will get all these images. Similarly, if we are doing it for the second grayscale image and the negative image, and when we execute this program, we get this one. That is, we are having one row and three columns. In the first column, original image, second column grayscale image, and third one is the negative image. Okay, now we will see the execution of the program using MATLAB. So here, this is the MATLAB. Now in the editor window, I have already copied the program. Okay, here I have copied the path of the image. You can choose any image you want. I have taken this image. Now we will execute this program. First I'll save it. Now run. So when you run it, you get this particular figure window, okay, where we have one row, three columns, and we have displayed all the three images. So you can see this is the original image, colored image. This is the grayscale. Then this is the negative of the image. So this is about creating the negative image from a colored image. Thank you.